So I'm at the Great Northern AI Summit, and I'm going to talk today on the subject of when AI becomes super intelligent. I'm going to look at questions like, when might that happen? Will we create consciousness within a computer? And if and when it does happen, what does it mean for the human race? Let's dive into the topic of the moment, when AI becomes super intelligent. And we're going to start the story with Gordon Moore, one of the founders of Intel Corporation, who in 1965 said that the number of transistors on a chip is going to double every year. Now, in 1975, he revised that estimate and said, no, it's going to double every 2 years. And maybe Gordon Moore, creator of Moore's Law, was looking 10 years ahead. But actually, to this day, Moore's Law has stayed more or less true, that doubling of the number of transistors every 2 years. We're now seeing tens of billions of transistors on the most recent chips today. What's very clear, looking for decades to come, we're going to see exponential growth and rapid growth in compute power, memory and storage, and bandwidth. So let's have a look what that actually means for us as a society. And there are some really obvious things. We're going to have even bigger TVs, even higher definition, lots more video on the internet. But there's lots of things, I think, that are very difficult to predict if we look forwards. So if I look back 25 years, then look at how the internet has completely changed society and the way we do business. You know, in 1995, who could have predicted social media, the cloud, video streaming, and things like the government's big push to get full fibre broadband to everybody at a time when the vast majority of people in the UK didn't use the internet, they didn't want the internet, and a lot of them didn't even know what the internet was. So if you look forwards, I think we've got equally difficult things to predict in the future, equally radical changes to society and business. Now, one thing that I do predict is actually not the creation of AI as such, but the creation of, maybe let's call it RI, real intelligence. Maybe we should call it TI, true intelligence, or maybe we should just call it intelligence. You know, some people call it AGI, artificial general intelligence. It's certainly my view that we will create true intelligence within a computer system in the not too distant future. And we might even create a conscious computer. So let's have a look at that statement, a conscious computer. So you imagine a robot who exhibits all the behaviors of a human, both emotional response and logical response. It would be quite difficult, I think, to say that robot is not conscious. And I hear what you're saying. You're saying, hang on a minute, surely there's more to consciousness than just a symphony of electrical signals dancing about between our circa 100 billion neurons across maybe 1,000 trillion synaptic connections. You know, as a species, we're alive, you know, we feel, we have a sense of self, we have a soul, maybe some magic that transcends the physical. Or do we? Well, what the science says is, of course, these feelings are real, but they're all created by the structure and electrical signals within our brains. And in fact, not all of our brain, but a very specific part of our brain, which is the posterior cortex, which, as far as we can tell, is where all conscious experiences happen within the brain. The two most popular theories of consciousness currently, global neuronal workspace says that computers of the future will be conscious. Integrated information theory, on the other hand, says programming for consciousness will never create a conscious computer. Well, does it even matter whether, to the human definition of consciousness, whether the machine is conscious or not? And I would say it doesn't really matter. What's much more important is, how will it think and what will it do? Let's move on now to the question of, when will it happen? So there was a survey done about 3 years ago 352 AI experts were surveyed. They were given this definition of high-level machine intelligence, HLMI, is achieved when unaided machines can accomplish every task better and more cheaply than human workers. And the respondents were asked to estimate the probability of HLMI arriving in future years. Now, this is the results, and there is a bit of a health warning over this graph because there was a wide spectrum of views. From some people were saying, well, it's definitely going to happen in 10 or 15 years. Other people were saying that it's unlikely even after 100 years. So a little bit of a health warning to average such a wide range of statistics. But if you do average them, they come out to round about 2060. And that's round about my own estimation of when this happened. This is in the next few decades. And really, whether it happens in 40 years or 80 years is sort of irrelevant in the grand scheme of things. The bigger question is, will it actually happen? And the vast majority of respondents said, this will definitely happen. It's just a question of when. Now, part of that survey, they also looked at interim steps that we would reach. And there's some interesting stuff here. So we talked about self-driving, driving a truck, in 7 years' time, working in retail 11 years' time, writing a best-selling book 2049. Well, maybe GPT-3 can do that earlier than that. Working as a surgeon 2053. So some really advanced stuff there. Now, as and when this happens, something very interesting is going to happen next. And that is the AI will overtake human intelligence to become super intelligent. So this is a graph from Jeremy Howard from one of his TED Talks that's pretty self-explanatory. Here's another chart. This is one from Nick Bostrom. And what Nick Bostrom said is, we're going to have to do a huge amount of AI research to get something that's as clever as a mouse, a huge amount more to get something that's clever as a chimp, a huge amount more to get AI to be as clever as what Nick Bostrom calls the village idiot. And then moments later, the AI will be as clever as Ed Witten. Ed Witten, one of the most accomplished mathematicians and physicists in the world today. But it's not going to stop at Ed Witten. It's going to go whizzing past and develop a level of intelligence that far exceeds anything that humans could achieve. Now, I was talking with my brother Dan in the pub, again, as you do, and we coined this acronym SMIDITHOM, which stands for the single most important discovery in the history of mankind. Let me go into a bit of detail what I mean by that. So look at humans. Humans have evolved. We have invented all sorts of good stuff: the wheel, the light bulb, the computer, the space shuttle. And one day we invent super intelligent AI, something that exceeds our intelligence. And the super intelligent AI goes on to invent everything else, all future inventions. So this one invention, quite unnervingly, is the last thing mankind ever needs to invent. Now, as and when that happens, there's going to be an enormous discontinuity in the pace of progress. So if you look at human progress measured by progress in technology, in maths, in physics, in medicine, in astronomy, it's been exponential. If you look back maybe over the last 1,000 years, and that's shown by this bottom line in my graph, which is on a log scale. As and when AI becomes super intelligent, we'll continue to see exponential progress in all of these areas, but the rate of progress will be undistinguishable. It'll be so much faster. And to illustrate this, I thought what I'd do is do a bit of a top trumps of the human brain versus super intelligent AI. And I'm going to start off with signal speed. So signal speed in my brain, about 200 meters a second. Signal speed in a computer, just short of the speed of light, about 1.5 million times faster. Size. So my head is 60 centimeters circumference. Size of an AI, it could fill a whole data center. It could distribute itself over the whole of the internet. Lifespan in the UK, average 81 years. AI could reasonably expect to be immortal. Time for smarter models to evolve. So look at Neanderthals, existed between 40 and 400,000 years ago. So tens of thousands of years for humans to evolve to smarter models. AI could evolve daily into smarter models. And finally, learning time is for being able to push forward the boundaries of knowledge. So going back to Ed Witten, he spent decades of focus to push forward the boundaries of quantum physics. AI could do that in seconds. So really, it would be like comparing the snail, which is the humans, with the racing car, which is the AI. And what it means is maybe 1,000 years of human advancement could be compressed into 6 months. Now, you might think, nah, that sounds far-fetched, but actually let's validate that by looking at some AI technology we know about, actually, that Matt Wilson has just mentioned, AlphaGo Zero. So AlphaGo Zero started with no knowledge of the game. 3 days of playing against itself, it became able to beat AlphaGo Lee, the previous program that had beaten Lee Siddle, one of the best human players in the world. And in 40 days, it became the best Go player on the planet. Now, Go is an old game invented in China 2,500 years ago. And during this learning process, AlphaGo Zero rediscovered a lot of the strategies that have been discovered by humans over the last 2,500 years. And then it went on to discover whole new strategies that never before have been seen in the game. So if you look back to Moore's law, we're doubling compute power every 2 years. So by 2060, we can reasonably expect computers to be 2 to the power 20 or 1 million times faster than they are today. So 40 days go down to 4 seconds. Through AI research, our algorithms will get more efficient. And in fact, AlphaGo Zero, despite being better than previous versions, was also used a lot less compute power. So there's another order of magnitude or 2 of saving in time. So 4 seconds goes down to 0.04 to 0.4 of a second. What that means is by 2060, using current technology, computers will be able to start with no knowledge and become the best Go player in the world in about 1/10 of a second. Now in 2060, humans will still have to dedicate a lifetime to the game to be far inferior players. So that gives you a sense of the disparity between what computers are capable of and what the human brain is capable of. Of course, the next big question is, well, is it safe? And this quote from the late Stephen Hawking: computers will overtake humans with AI within the next 100 years. When that happens, we need to make sure that the computers have goals aligned with ours. And of course, it's not just the goal that matters, it's how you get to the goal. Do you get to the goal adhering to the values that are important to us? Let's have a look at that. Values, the challenge of defining our values. And to look at this, I want to ask you a question, or for you to think about this question. Do you think it's right that women are allowed to vote today? And you think, well, what a strange question, and in fact, quite a potentially offensive question to ask. But let's have a look at the history in the UK. So prior to 1918, women couldn't vote in the UK, and it wasn't until 1928 that women got the right to vote on equal terms to men. So the whole point of this slide is to say that values that were widely accepted just over 100 years ago are offensive today. Values are not fixed, they evolve over time. We don't see it day to day, we don't see it year to year necessarily, but decade to decade, you can see that our values are evolving. So we accept that and we think, okay, let's take a snapshot of our values today. And again, we run into trouble. Let's look at driverless cars. So Nature did a survey a couple of years ago of 2.3 million people around the world. And they gave 13 scenarios where someone's death was inevitable in a car accident. And they asked the participants, who do you think should live? Who do you think should die? Who is more important here to save? And I'll jump straight to the conclusion here, where really, depending on where in the world you are, people had quite different views. So in the southern areas, females and higher status people took priority. In the eastern areas, pedestrians and the lawful took priority. In the western areas, there was a preference for inaction. And one of the researchers and co-authors of the study says, people who think about machine ethics make it sound like you can come up with a perfect set of rules for robots. And what we show here with data is that there are no universal rules. So let's try and sum up that and make some predictions for the future? Well, I certainly believe that we will create superintelligence and a super intelligent being within the next few decades. In fact, more precisely, we'll create an AI that has a similar level of intelligence to us, but with the ability to create slightly more intelligent versions of itself. And very quickly, that iteration will happen to the point where it runs away and becomes super intelligent, using a process that we less and less will understand. When that happens, the consequences are very difficult to predict. And when I try and think about predicting them, I feel like this chimpanzee trying to predict the accomplishments of mankind. I think it's very important that just as a parent would send off their children to the world with the best education and value set that they can, it's very important that we do that with AI. So we've also already mentioned OpenAI in this session. OpenAI has a mission to ensure that artificial general intelligence benefits all of humanity. Importantly, it's a not-for-profit organization. Now, of course, there's plenty of for-profit organizations that are also working on AI. And if you think there's problems today with the capitalist system, and I certainly do, can you imagine a world where a for-profit entity deploys super intelligent AI with the prime directive of maximizing the financial return for a select few shareholders? Could be very problematic. Some people think it'll be the end of humanity. Some people think it'll be massively beneficial. I want to throw something else into the pot as well. What about instincts? So beneath our veneer of civilization, we are still very much driven by our primeval instincts to survive and reproduce. So what about AI? What will its instincts be? Actually, will it just make its own mind up about what its priorities should be, irrespective of what we do, in the same way, actually, that we make our own priorities without reference to our primeval ancestors? I think it's very unlikely, in fact, that we would be able to control a super intelligent being, just as a chimpanzee couldn't control the actions of a human. So all we can do is set it off on the best possible path and hope things work out well. Now, if that sounds a little bit ominous, then I want to just share a note of optimism. We humans have an innate tendency to violence. And we have that because it's in our nature. It's been an essential part of evolution, just as it is with many other species on Earth. So when we think about intelligent machines, we think about them in our own image, also having this innate tendency to violence. But in fact, there's no reason at all for an intelligent machine to be violent, because unlike humans, violence is not necessary for its evolution. You know, if we can program the AI to value things like peace, harmony, and diversity, then it could evolve and prosper, coexisting with all life on Earth without the human race being at all threatened at any point. Now, I'm going to finish off, because obviously Zen Internet is an internet company, I'll finish off with some thoughts on what part the internet will play in this trajectory, with some reference to some Hollywood movies. So, will the internet be the brain like it was in Terminator 3? Or will it be like in iRobot, where Vicky is like them in a mainframe computer room, contained within one room? Or will it be like Chappie, where all the intelligence is within the robot's head? You know, really, whether the internet is the brain or whether it's being used as a learning and communications medium, the implications for the human race are going to be revolutionary. It certainly will be the biggest change to society since the Industrial Revolution, providing potentially enormous opportunities and benefits for us, but also potentially enormous challenges. I think actually it could be the most significant event in the Earth's history since the creation of life itself. Thank you very much for listening.